So let's take a look at the way we graph rational functions, and we're using that frame to help us do that. So this is the front side, I guess you could call it the back side. You got these two sides. So when we're graphing rationals, okay, the keys to it, it's about finding the asymptotes, holes, and x-intercepts. That is the main stuff that we need to do, and then we can find that graph. So the easiest thing to start with is our horizontal asymptote. Okay, and we can zoom in here a bit, make it easier to see. Okay, so those horizontal asymptotes, okay, what you're doing is you're looking at the highest degree of the numerator and the denominator. The numerator they call m, the denominator n. And based off of that, it's going to determine what type of horizontal asymptote you have. There's three types. Okay, the first is that the x-axis is the asymptote, or that y equals 0, same thing. The second is that the coefficients form that fraction, and that becomes your asymptote, that line. Okay. The third one is that you have a slant asymptote. Okay, that you have a linear equation for your asymptote, and you have to use long division to figure that one out. Okay, so if the top is bigger than the bottom, the top degree is bigger than the bottom degree, that's when you have a slant one. And then you use long division on that rational function to come up with a linear equation which represents your asymptote. Okay. The second one is if they're equal. If they're equal, see x squared and x squared, so they're equal. You take the coefficient, the number in front of that highest degree, make it a fraction, 3 over 4, simplify it if necessary, and that becomes your horizontal asymptote. And then that third was if the top is less than the bottom, so like x to the first over x squared, then your x-axis is the asymptote. That's probably the easiest one. So pretty much you can just look at it and determine what type of asymptote you have, and in two of the cases very quickly come up with those asymptotes. In the third case, there's quite a bit more work that you have to do for that. Okay, so now let's kind of zoom it here because we're going to kind of do these two together. So the horizontal asymptote is usually where you start. Then you're going to have to factor and deal with your rational to find the x-intercepts and the vertical asymptote, which also includes holes. It's kind of the same step. All three of these you're kind of doing at the same time. Okay. Now, here's kind of the basic idea. After you factor it, if any of those factors cancel, that's when you have a hole. So look at this example right here. I factored it to x plus 1 times x plus 2 over x plus 1 times x plus 3. Those x plus 1s can cancel. That's what it means. So you take that x plus 1, you set it equal to 0, solve for x, that's the x value. Then use your simplified function, just that, plug in for x, your x value, solve. That'll give you your y value, and that's where your hole is. That's the point where your hole is. Okay, so that's kind of the next one. Horizontal asymptote, factor. Does anything eliminate? If it does, there's a hole. If it doesn't, then you don't have to worry about the hole. Okay, so that's the hole. Then, once you've got that canceled out and you're left with just this simple one, well then, to find the x-intercept, you take the top, set it equal to 0. So you set the numerator equal to 0 once you've simplified as far as possible. For the vertical asymptote, you set the denominator equal to 0. Okay, so that vertical asymptote, you take the denominator, set it equal to 0, solve for x, that becomes your vertical line. X at -3 would give us our vertical line, and that would be our answer. Okay, that's for the vertical asymptote. For the x-intercept, you take the top, set it equal to 0, solve it. That's where on the x-axis your x-intercept is at -2. So if I were to graph this one, okay, my highest degree on both of these would be x squared. So same degree means that I take the coefficients 1 over 1, so it would be 1. So if I was graphing this, my horizontal asymptote would be at y equals 1. My vertical asymptote, we said, was -3, so it would be right about here. Okay, that gives us those boundaries. My x-intercept would be -2, so I know there's an x-intercept here. My whole would be at -1, 1/2, so it would be like up right here. That tells me that, that's the 4 pieces of information: horizontal asymptote, vertical asymptote, whole, and x-intercept. And then I know that because I've got this part, that's the portion I'm going, and it's going to get close to those asymptotes as we go. And then we go to that diagonal side to get the other piece. Okay, so that's kind of the basics there of it. And there we go. So if you need to, pause that again, take a look at that side. So here's basically another example. So let's take a look at this example. So here's our equation: 2x squared plus 2x minus 24 over x squared plus 6x plus 8. So we look at those degrees. So they have the same x squared and x squared, so we take the coefficients. So 2 over 1, so horizontal asymptote 2 over 1, because m was 2 and n was 2. So there's our horizontal asymptote right there, at y equals 2. Okay, now we're done with the horizontal. So then we factor it, and we come up with this for our factored. Okay, now we're able to eliminate that x plus 4, so that goes with our whole, right? So x plus 4 equals 0, subtract 4, we get x equals -4. So I know somewhere here at -4, up or down, I've got a whole. So then we use this piece. Okay, they took the -4, put it in for x, solved it, we ended up with 3.5. So at 3.5, that's where our whole is. Okay, now we're done with that. So then we take this piece and we split it into the numerator goes for our x-intercept, the denominator goes for our vertical asymptote. Set them equal to 0. So notice we set a lot of things equal to 0 here. X equals 3, there's our x-intercept. X equals -2, there's our vertical asymptote. Okay, then because the x-intercept's here, I know that I draw this graph on this side, coming up through it, and then back to the other one. Because our whole is here, I know that this is where the other side is. So basically, using these 4 aspects, we can get that quick idea of what the graph looks like. Now, is this exactly what it looks like, these lines hydrum? Probably not, but we've got the major points, and that's all we need for right now. Okay, so let's take a look at this one. So we start off by going after the horizontal asymptote. Okay, that's like x to the first, that's 2, so top is bigger than the bottom. M is 1, n is 2. So when the top's bigger than the bottom, remember looking back at this, the x-intercepts our asymptote. So we draw our horizontal asymptote here, or at that line, y equals 0. Okay, now we've got a factor. Okay, so the top we can factor out a -1, and we'd be left with x plus 4. The bottom, factors of 8, that would add up to 6. Positive 4, positive 2 would give us positive 6. So x plus 4 becomes x plus 2. So we should notice right off the bat, we're going to eliminate something. Okay, that means we have a whole. So I go x plus 4 equals 0. Subtract 4 from both sides. We get x equals -4. So that's the x value. The leftover is -1 over x plus 2. So I put in that -4 for x. and simplify. So negative 4 plus 2 is negative 2. Negative 1 over negative 2 is positive 1/2. So my y value is 1/2. So at negative 4 up to 1/2, we know we've got a whole. Okay. Then we look at the top for an x-intercept. And because our horizontal asymptote is on the x-axis, most likely we don't have one. And we don't have an x value, so there is no x-intercept, so we don't worry about that. There has to be an x. Then we do our vertical asymptote. So we take the bottom, set it equal to 0, the denominator, and we get x equals negative 2. So at negative 2 is our vertical asymptote. Then knowing where our hole is, we know that we can draw our graph over this. It goes up to our hole, not through it, and then up to the next. Then we remember as we go up here, it's like we're going off screen, so we appear at the bottom on the other side of that, and we just kind of draw ours, sketch it as best we can. So there's how we do it. And there's the notes to go along with it.